there was there an announcement for the talk or not? And then Todd kind of quickly sent something out. I'm very happy to welcome Zeray Alemseged, and apologies for mispronouncing your well. Okay. Zeray is a paleoanthropologist with a focus on the origin and diversification of early hominids in the late Miocene, early Pliocene. And he is very famous for his studies on Ceylon, the roughly 3 million year old female Australopithecus afarensis that was found in Ethiopia. He has published a lot of papers in prestigious journal, Nature, Science, PNAS, and so on. And got his PhD in paleoanthropology in 1998 from the University of Paris and the National Museum of Natural History in Paris. I think working at the Field Museum, I shouldn't say this, but I think the Natural History Museum in Paris is probably one of the most beautiful, at least most beautiful settings of all natural history museums I have seen in the world. Before he got his master's from the University of Montpellier and his bachelor in geology from Addis Ababa University. Then as a postdoc, he worked at the Institute of Human Origins in the School of Human Evolution and Social Change at Arizona State University, and then moved back to Europe to become a senior researcher at the Department of Human Evolution at the Max Planck Institute for Evolutionary Anthropology in Leipzig in Germany. And he stayed there until 2008, and then was at Cal Academy as a curator and chief of anthropology for a couple of years, before then in 2016 moving to the University of Chicago, where he was appointed then later as a Donald Pritzker Professor at the university in 2018. Zeray is a fellow of the American Association for the Advancement of Science and was also 2021 elected to the American Academy of Arts and Sciences. So welcome, Zeray, and I'm looking forward to your presentation. Thanks.
Thank you, Thorsten. That's really great to be here at the Field Museum. I'm not new to museums. As the person said, I was a curator of anthropology for quite some time at the Cal Academy when I moved from Germany. So I understand your secrets. So I know. But really, I must underscore, in case I forget, the importance of museums, because I was frustrated when I was at the Cal Academy that some people don't really understand the significance. Yes, it's great to do research, great to do to invent, but this museums really put everything together. I think that's how I see it. So I'm happy to be here. In fact, before I moved to the Cal Academy, the first time I gave a lecture in the US also was here in 2007 after the discovery of the specimen that I'm going to discuss today, part of the lecture. So really great to be back and see some of my colleagues, John. So thank you for inviting me. I see also Julia and so on. So I was told this is a public lecture. I asked. So what I did is present something that would be inclusive. So if some of it is basic, it's intentional. If some of it is not, it's intentional. Because I was told to give to the public, to speak to the public. But I see also many scientists, if not all, here also. So the question, what fossils or fossil hominids reveal about being human is really the essence of both my expertise, but also what I'm passionate about. So if you ask me, what do you do at the University of Chicago, or when I was in Germany or France, or I have been all over. The question I'm interested in is, what are the key milestone events in human evolution that ultimately led to this big-brained, sophisticated, invasive species that calls others invasive, actually. What are the different stages? So what I will do, of course, I can't talk about everything, is give you some examples based on the creatures that I work on, i.e. Australopithecus. But I know here in the museum it's preaching to the choir, but why does that matter? But I think it's important, especially these days, to talk about these topics, because we may understand the importance of answering those questions, but I sometimes wonder or worry if everyone understand or appreciate the importance of those questions, those answers, and broadly the importance of knowledge these days. So why does it matter? Well, it matters because understanding both our uniqueness, what makes us unique as a species, but also the shared attributes or commonalities that we have with other species is really important. I declare we are primates. And when you see this question, how we became human on the cover of Time magazine, clearly it's of interest not only to the scientists, but also to the readers of Time magazine. And we can assume that not all of them are scientists. Well, but it is true also that we have many unique features. We speak, right? And I don't know of other species that has articulated language, not broadly defined, but as I am doing it right now. We can write, we love vanity, be it in the form of this young man's tattoo or Julia Roberts' dress, or the lovely lady from Ethiopia who goes through the pain of piercing her lips to put plates, because for her, that's what beauty is. And all of that really raises the human species to becoming this worshipping primate, which is also capable of seeing the invisible. I think we have religion, traditional beliefs, etc., etc. And all of that combined, I would say, would lead to the innovative primate that we are, that currently possesses unprecedented longevity in terms of lifespan. I don't know if you know, but I don't think there is any other species that has an institute to study how old it is. So yes, we have many unique attributes as humans. And okay, we can celebrate that. But those imaginations, innovations, and longevity combined have also made us this highly technological and replicating primate. Our population size today stands at a whopping 8 billion people. And if you compare it to chimpanzees, whom we share a common ancestor only 6 to 7 million years ago, their population size is maybe 200,000. So we had a common ancestor together 7 million years ago. We stand at 8 billion. They only are now represented by 200,000. And really, thank you to the Field Museum and other museums for hosting those collections that are actually fundamentally important for the conservation purposes, but also for my study and research. My students come here, spend time, and I want to acknowledge all of the people involved in the conservation of those collections. So we are a highly replicating species, which means that we also are therefore pervasive and expansive. There is no other primate, if you ignore the zoo, that lives north and south of the tropics, except a macaque species in Japan. So basically, we are a tropical primate. I ask my students at the University of Chicago, they don't belong here. When I teach in winter, they say, oh, we do belong here. Well, go out naked if you indeed belong here. So yeah, it is a very expansive and pervasive species. And that does not seem to stop as we know it. We clearly have captured the planet. We've besieged the moon, we're patrolling Mars, and that will definitely continue. And I really would like to underscore, we're doing that because we have universities and museums. So if you want to cut funding from Harvard, go for it. But you're really putting the species itself at a risk, in my opinion. So this movement, as we were capturing the planet and beyond, have done damages, as you guys very well are aware. When we went to, as a species, that is, Homo sapiens, when we moved to Australia, 14 out of the 16 megafauna were decimated. In South America, 34 were gone. In North America, 50 out of 60 were gone, etc. So yeah, we do damage. And while doing that, when we moved to Europe and other places, Asia, we also managed to either assimilate or remove species like Neanderthals, Denisovans, Homo floresiensis. So we're not the kindest species, but those are the facts. So destructive, but I would like to underscore the fact that we are also highly trainable species. And not all is doom and gloom, in my opinion. We can decide to drop or conserve the planet. And I repeat again, and that's why we need to understand biodiversity. And that's why places like my university and your museum are important. But to drop or to conserve, we must understand our place in nature. And that's why we have collections. Here is the Tree of Life. You can see many groups. Many of you work on all those, so you know them more. But if you were to remove the coral reefs, I think you will destabilize the entire planetary ecosystem. But you can't find humans here. I don't have a cursor, but that's it. But it's a tiny species with huge impact also. So knowing our place in nature is important. Which brings me to my work. And that is, how do you then understand our place in nature? Well, all of you do that when John works on birds or mammals, others, he's doing it. When Julian works on little rats, that's what he's doing. When I work on crazy human beings, that's what I'm doing. So all of us have our own way of looking at that question of what makes us human and how we became human. So we can use, therefore, primatology, so we can understand our closest cousins. We can use genetics. We can use fossils like I do, and I'll exemplify that. But a species like us cannot be fully understood without understanding the brain, and if we can, even the mind, and that's the study of neurosciences, et cetera, et cetera. So what we need is that we need a comprehensive approach, a collaborative approach to understand those what makes us human, how we became what we are, and what our place is in nature, so we can have a sense of what our role should be in nature. And of course, don't forget the archaeological record also. When my kids go from 5 to 6 or 7, they get excited. And they say, wow, yeah, this is fancy, this is great, this is sophisticated. But you know, the first person, 3.5 million years ago, who picked up the rock and shaped it with the intention of using it to carve meat of the bone or access the bone marrow is, I think, smarter than that transition is even more prominent to me than the transition from iPhone to pen or et cetera, et cetera. But I'm not saying it's not good, but they're great tools. But it's important to put things in perspective. So how do we therefore understand our place in nature? By deciphering our evolutionary history. And what I will do is use the fossil record as an example. I must underscore that human evolutionary sciences is a thriving science of the past with promise and with a big future. The power of molecular biology, this novel imaging and visualization techniques, CT scanning, synchrotron, the study of neurosciences, fieldwork are really transforming the study of human evolution. And if you look here, all of those papers on the cover pages of Nature and Science, and I have contributed my share, as the person said, but also the Financial Times and Washington Post and Time Magazine clearly shows that what we do is both a scientific and a human endeavor. In fact, the Nobel Prize in 2022 went to Svante Pääbo, who is a scientist in Germany, for his work on ancient DNA. And that Nobel Prize is Nobel Prize in medicine. So there is a broader application of what we do in the study of human evolution beyond the esoteric and exciting questions that are also, I think, important. Okay, given that background, now I think that was the basics, and I had to do it as a reminder. So I know many of you know that, but it's important, I think, sometimes to remind us of the basics. If you were to look at the place of humans in the broader biodiversity, of course, we are primates. Specifically, we're great apes, and we share a common ancestor with the chimpanzees. We share a common ancestor sometime around 7 million years ago with the chimpanzees. And both of us share a common ancestor with the gorilla sometime around 10 million years ago. And the three of us share a common ancestor with the orangs sometime around, let's say, 12 to 15 million years ago, and it goes all the way to the origin of life. So what I do as a paleoanthropologist is to try to find the evidence, both archaeological and fossil, so I can fill in this gap, so I can identify the key milestone events in human evolution. When did we stand up? When did we start to use stone tools? When did we acquire this body proportion with short arms relative to the longer arms that we have, which is reversed in chimpanzees, for example? When did we acquire this huge brain, which eventually made us the symbolic species that we are, which is interested in its own origins? And I don't know of any other species that really is investigating its own origins, as far as I know. So when we do that, therefore, 20 that have existed, some of them dead end, some of them ancestral to our species over the past 7 million years. And what is interesting is 100 years ago, this is all we had. In fact, even the one in the middle, Australopithecus africanus, was discovered exactly 100 years ago by Raymond Dart. I'll come back to that. All we had was the evidence from Asia and Europe. And we thought human ancestry didn't go back far in time. But today, thanks to the paleontological record, we know that our ancestry is both diverse and rather bushy. So I really would like to celebrate Raymond Dart, who exactly in 1925 published a seminal paper introducing the tongue tide, and basically the first species from Africa, South Africa, Australopithecus africanus, which heralded the fossils belong to a human ancestor. There was a huge resistance at that point, especially from the British intelligentsia, because at that point, large brain was the sine qua non for being a member of the human family tree. And what he found is a bipedal creature, but with a small brain. So many of those paleoanthropologists didn't take him seriously for, I think, 30 years. Because also they had, you probably know, the Piltdown, which is a hoax of fake discovery, which had a mandible of an orangutan and the cranium of a human. And for them, it was representative of what they imagined, meaning humans must have a big brain, and therefore the fake discovery was real, and this one was an ape. But he somehow was vindicated after 30, 40 years of more research was done, and we know that it belongs to the genus Australopithecus. That work in South Africa inspired work in Eastern Africa, which led to the discovery of the famous Lucy. You can see Johansen over there, and all these East African fossils that, of course, are foundational for my own research. And in many ways, the discovery that I'm going to discuss, the Dikika child or Salam, just in the tail end, a newcomer relatively in the history of discoveries in that generational continuity. So therefore, how did I discover and what is the significance of that find? I'm going to now take you out to the field and then to the lab and talk about the significance of that fossil. And my goal is to show how these fossils are helping us to answer those questions and what these so-called transitional species looked 3 or 4 or 2 million years ago. So the site is called Dikika. That's in the Afar Depression, which is in the Horn of Africa, Eastern Africa. You have the Red Sea on top, you have the Gulf of Aden, and there is a new creation of a new sea here as we speak. Africa is splitting, and maybe in 10 million years, you will have an ocean separating Africa. Maybe help us reduce the fights about port saying things next. But this in 10 million years, maybe. Many people, maybe some of you don't remember, but the Red Sea was not there 30 million years ago. And therefore, the Arabian Plate was part of Africa. So that area, therefore, is highly tectonically dynamic, where you have so many volcanic activities, earthquakes, bringing in these ancient rocks that were buried 3, 4, 5, 6 million years ago. In many ways, that area is a paleoanthropological hotspot because many of the species that you know, Australopithecus afarensis, the Lucy species, Ardipithecus, Garhi, et cetera, come from that broader area. Of course, I must acknowledge the people who make those things happen. This is a portion of my team. And you need, of course, a geologist, an archaeologist, a paleontologist, a paleoecologist, etc. And of course, students, very critical. And you need these days, as you all know, an international and interdisciplinary or multidisciplinary team to do what we do and to really tell the story that I'm telling you. So in many ways, I represent many, many people as I stand here. If you want to delve further to what I'm going to discuss today, I published last year a paper, recently anyway, a good review, in my opinion, of what I think of Australopithecus. So I invite you to have a look if interested. So when you go to these sites, this is what you see. I mentioned the tongue child as a discovery made by Raymond Dart. Many of the sites in South Africa are cave sites. And if there are geologists here, you don't want to be a cave geologist. That's a very complex endeavor. Really, I tip my hat to them. They're very complex because the deposition of those sediments is happening in a haphazardous or random manner, depending on the dynamics of the cave formation. What we have in Eastern Africa are these lakes where you have deposition of layer by layer of these sediments, including that white band that you see, which represents a volcano that erupted 3.42 million years ago. So in many ways, really, it's a textbook stratigraphy. I mean, you can go around the US and find many beautiful sites, maybe older. So the fact that these are layered, and then you can put the fossils in a good context is really foundational for both the geochronology, but also for our understanding of the temporal and spatial distribution of the fossils that we find, and for the better understanding of taphonomy, meaning the history of the fossil, meaning between the dying animal all the way to the discovery, the fossils are passing through a process which is very complex also. So when we say 3.42 million years old, we are really as precise as you can get. And on the other side is where Lucy was found, the Hadar site. On this side is Dikika, where I do fieldwork with my colleagues. So the age of the sediments, well, first the sediments are fluvial-lacustrine, meaning river and lake deposits. The age of the sediments is over 3 million years. It's very remote. It's hot. Access is very difficult. In fact, when I started my work in 99, I was the first person to drive a car to the site. And I remember the cows had never seen some big white carnivore. That's my Land Cruiser, and they were just running up. After like some years, actually, they became our good friends. But it's just remote. And what we do is really spend hours and hours and days after days and months in camps. And what do you find? This is probably the frustrating part of my presentation, the slide, because I can't tell you as much as I should tell. And that is, when people like myself, who are paleoanthropologists, go to these sites, we're interested in the hominin fossils, but only less than 5.5, less than 1% of what you find are from hominins or human ancestors. The majority of fossils that you find are, you can see a tusk of an elephant, which is in situ, right in the sediment. You have a beautifully preserved cranium, skull of a monkey over there. You have a hippopotamus here. I'm sitting next to a rhino mandible over there. Crocodiles. So the site that you just saw, which is empty, dry, and barren, was able to host creatures like that in abundance. At my site, when we walk, we have to pay attention to not step on fossils. It's just all over. In fact, we don't even collect some of the postcranial elements of large mammals like elephants and hippos and rhinos, because there wouldn't be enough storage. The way to picture the site is you have, imagine some African park, like the Serengeti Park or something like that, and the entire fauna and flora will collapse and be buried. And what you have is a sedimentary archive containing this ancient park, but preserved in the form of these fossils. And these are the fossils that actually tell us about the changing environmental conditions. And humans or human ancestors like Australopithecus are just one tiny portion of that faunal assemblage or biodiversity in the same way as that slide I showed you earlier. So that's why I told you, well, it could be another series of lectures on hippos and elephants. And if Thorsten, you invite me again, I'm happy to come back. Or I'll invite one of my colleagues who work on that. But within this landscape or context or assemblage, use and find the things that I personally work on. First one's like this one. And what is this? This is an individual, I'll tell you the age and death later, but who belongs to the species Australopithecus afarensis, which means the Lucy species, dated to 3.32 million years ago, comes from a site called Dakika in Ethiopia. And the question is, what is it, and what did we learn from it? Well, by the way, you have the sculpture of this individual and also Lucy upstairs here in the Field Museum. I hope it's still there. And actually, there is one in Ethiopia where it was found. There is one in California where I was a curator, and this is the third one. So the museum and Bob Martin and I worked together to make that happen. So of course, the tall one is Lucy, and the little one is Dakika. It's also called Salam, which means peace in Ethiopian languages. One thing I underscored earlier is the use of visualization techniques, which many of you here use, CT scan synchrotron. In this case, these are images of synchrotron. So this is the skeleton, the skull. What you see there is the result of this imaging of the inside of the jaw. So what you see here are the milk teeth, the baby teeth. What you don't see here are those adult teeth which do not have the roots yet. So meaning if you go out now, grab a child, 6, 7, how many teeth do you think they will have? Okay, I'll spare you. They have 42 teeth in their teeth. As a grown-up, you will have maybe maximum of 32. But we take the 4 out, so we have what, 28. This child had 42 teeth in his mouth. And what we did when we published the Nature paper is, okay, if this individual was a chimpanzee, how old would it have been to accumulate this amount of teeth? And we said, well, maybe 4. How about if it was a human? Because we grow slowly. We said 2. So let's take the average. We said 3. But of course, we know they are not human. They are not chimpanzees. They are called Australopithecus afarensis. But the new technique, especially the synchrotron technology, allows you today to count the daily growth lines of the crown of the animal, the molar. What it means is you can count day 1, day 2, day 3. You can actually see the day the child was born as a perturbed region of the tooth. That is how powerful these techniques are. So what you do is, so we know baby was born at this level of the dental development, then all you need to do is count the daily growth lines, as you see it there, and it gave us an age of death of 2.4. As I said, we were wrong when we said 3, because these guys were neither humans nor chimpanzees. They were Australopithecus. I think these techniques must be really celebrated and really gives you a better understanding of the magic of both synchrotron and technology. Okay, so the individual died at the age of 2.4, and we know there is sexual dimorphism in Australopithecus afarensis, like you see it in gorillas, meaning males are larger than females. Males have larger canine than females. And we measured the still developing, but not erupting, has not erupted yet, of canine, and it was very small. It was within the average for female afarensis. That's how we know it was a she. So what we have in that skeleton is a little girl who died 3.2 million years ago at the age of 2. Now, given that information, which is very precious information, we can now go back and ask questions. The first question is, what is it? What is it? Well, the tongue child, which is a holotype or type specimen of Australopithecus, was a juvenile, and we now have the opportunity to compare apples and apples. And I don't want to delve into the details, but it's clearly different from the tongue child, therefore, and also similar to some fragmentary previously discovered Australopithecus afarensis. Therefore, it belongs to the Lucy species. That's number one. And because many of the fossils that we find are from adult individuals, we really didn't know how this early humans grew. Now we have the opportunity to look at the female, male, and the child and see how things change during ontogeny or growth, as you can see in the chip. Well, even us, we don't really necessarily look the way we looked when we were 5 or 6, even 20. Things change. So that transformation can now be captured in the form of change of shape and form during ontogeny. Is now we can in fact my student Yared, who is somewhere here, is really focusing on that question, and he's going to tell us what is changing, what's not changing. I have some rudimentary ideas, but my point here is when you find a juvenile, it gives you a new set of information that you don't have from the adults. That's also an important thing. The other question that really lingered for a long time about Australopithecus afarensis was whether, oh, by the way, I prepared that when I was at the Cal Academy, and it's really now popular, people like it. What it shows you is, Lucy in the middle, chimpanzee on the left, and then you have humans. And what it's showing is what is similar between Lucy and chimp, and what is similar between humans and Lucy. But the question whether Australopithecus, we know that no one is questioning they were bipedal, they were upright walkers, because that's a hallmark of being human, especially for the earlier species. But the question was, okay, then if they are bipedal, what do we make of the ape-like characters that are found in the otherwise bipedal Australopithecus afarensis? Is really an important question. And the discussion was really so polarized for four decades. And some people still don't talk to each other because of that conversation. And the answer they brought to the table was, some would say, well, those ape-like features in an otherwise upright creature were there because they were useful for its adaptation, therefore they were used for climbing. And the other would say, no, they were just retentions from the ancestral condition, the more ape-like condition. So they were not useful they were not adaptive, therefore they were just retentions. And what this skeleton did, the new discovery did, is it gave us some features like the scapula. This is at the Musée de l'Homme in France. It's the giant scapula. I don't know why they chose the scapula, but I like the picture. So the scapula, which is pepper thin, is not really preserved in the fossil record. But we have both of them in the Stikika child in the new fossil. And what it shows is that the glenoid cavity, meaning the joint of your shoulder, which takes the proximal humerus, is oriented superiorly upwards. And chimpanzees have that. That's number one. The fingers are long and curved. And climbing apes have long and curved fingers. The inner ear, which again, thanks to the technology, you can go look at the labyrinth, has a smaller posterior and anterior semicircular canals. Larger semicircular canals characterize humans where you have the head and the shoulder decoupled. That's why I can comfortably do this. You can ask a chimpanzee to do it, but it's going to give you this. Also, when you see a baseball player, or I'm not fit enough, I can do this, but a chimpanzee would do this. So the shoulder and the head is decoupled in humans. That's why I can do this comfortably. And that's what the semicircular canal. So many features clearly suggest that these guys were, of course, bipedal, but also had this adaptation for climbing. And really, that should not be surprising. When you look at chimpanzees and gorillas today, when they're little, they climb a lot. That's it, climbing. As they grow older, they become highly terrestrial metal walkers, body size. But they never give up. Even the big ones, they never give up the trees because that's where they feed, that's where they nest, and that's where they avoid maybe not predators, but humans. So what may have happened in Australopithecus is therefore those ape-like features were indeed relevant for its survival. They were significant. But when afferences came down, or they were bipedal, not knuckle walkers, but they needed that small ability to climb for nesting, climbing, and avoid predators. Remember, we had saber-toothed cat surrounding them, giant cats, dogs. There is an otter species which was as big as a small donkey. Can you imagine? In Hydriodon. So I think that discussion is now pretty much sealed, in my opinion. Therefore, Australopithecus was climbing at least as much as African apes for nesting, feeding, and avoiding predators, but walked on two legs, one on ground, unlike gorillas and chimpanzees who knuckle walk. So why am I telling you all these things? It's because that's how we know what happened at any given time during that course of human evolution. And we can have now an idea of what the key milestone events were. Therefore, we can have access to the trajectory of our evolution after we separated from the chimpanzees. And now I'm telling you just that story that happened 3.5 million years ago. We can also ask complex questions. Was there childhood in Australopithecus? By childhood, I simply mean, was there dependence of infants or juveniles on adults like we do it in humans? Many of you are probably parents, I am. And when they're little, human children are very expensive, time-wise. And then when they start teaching, you have to also buy food. And then high school and college, and some actually stay on. So we are very dependent species. And if you're helpless and dependent, then the brain, which is really huge, is gonna continue to grow. Or because you have to grow your brain after birth, because it's huge, you need someone to take care of you. When you look at an antelope being born, they're born and they start running. Chimpanzees are not as fast as antelopes, but they can manage. At the age of 2.5, they can forage for fruits and leaves. Humans do wait and depend a lot. That's what I mean by childhood. And this skeleton, again, helps us address when could that have potentially emerged in our evolutionary history. And to do that, again, the techniques allow you to clean the bones virtually on your computer and have access to the brain, and you can measure it. So the question is simple. By age, because I told you the individual died at the age of 2.4, By age 2.4 year, with a brain size of 250 cc, that's what it is, only 68% of the adult value is formed in this species, Australopithecus afarensis. Which means chimpanzees would have formed over 90% of their brains by that age. So we think we see some evidence for this, at least rudimentary, call it childhood or dependence of these early humans on caregivers, call them parents or others. Therefore, while they were climbing like chimpanzees, despite being bipedal, their brain was growing more like in humans, meaning slowly. And that indicates some incipient type of childhood in that species. And this is despite the fact that the configuration or organization of the brain was ape-like. That's why I said the neither humans nor chimpanzees. In humans, we have this huge prefrontal cortex, and compared to the visual cortex, this is giant. So our visual cortex is pushed back. It's a really tiny portion of our brain. In chimpanzees, the visual cortex is much more developed, meaning in terms of proportion, you will have more visual cortex in chimpanzees compared to the anterior part of the brain compared to, if you compare humans and chimpanzees. And what you see, this is the fossil. That is the visual cortex area. This is the visual cortex area. If I don't have a human, but a human would be much smaller. So if it was growing like in humans, it's actually chimp-like in terms of organization. Yeah, because evolution is not a jump, it's a process, it's a mosaic. And finally, I will ask the question, did Australopithecus use tools? This question is really important because many of you know the species known as Homo habilis, which means Homo, the handy man. I think it should be the handy human, but it says Homo habilis is the handyman. So when it was named in 1964, one of the key attributes given to it were that it was able to use and make stone tools as opposed to other more primitive species or living great apes. And working at the same site, only 200 meters from the site where that skeleton was discovered, we found that some bones that we thought were carrying or bearing marks that suggest an early hominin wielding sharp-edged stone tools to carve meat of the bone or access the bone marrow. In other words, cut marks from the site where the only known species is Australopithecus afarensis suggests that maybe we had some early hominins, in this case Australopithecus afarensis, because that's the only species that we have, were wielding stone tools to carve meat of the bone. Remember, this would then take that behavior 800,000 years before Homo habilis. So in many ways, it was a wrong thing to say. But for us, the evidence suggested that, and we published it nowhere else, but on the cover page of Nature in 2010. And the reactions were mixed, and I'm going to go fast here. But only 5 years after, our colleagues working in Kenya found stone tools that are dated to exactly 3.3 million years ago. So for me, the older paradigm, or at least theoretical framework, must be revised. And while more work and evidence is needed, the stone tool used in making Australopithecus like hominin is not really a surprise. Chimpanzees and capuchins and many other primates do use stone tools, really. And data on behavior, primate behavior, early hominin hand morphology and taphonomy really dictates that we reevaluate our theoretical framework. So it set a good new theoretical framework, and many colleagues are now not ignoring the sites that are older than 2.5, and they're trying to see if they find the evidence or not. In fact, for me, this is a greater contribution to science than even the skeleton, because it's really helping us to go out from the obsession, Homo, the stone tool maker or user, but not others. Why? Because they're primitive or they're too old. Therefore, in summary, if you ask me, what is the new picture of Australopithecus today? They were biped, but climbers, had small brain with a protracted development. They consumed considerable grass-based diet. They were using tools and potentially supplemented that with animal resources, as I just described. They lived in a mosaic woodland environment and gave rise to the genus Homo. So in summary, and this is, if you push in time and go to the emergence of Homo sapiens in Africa 200,000 years ago, because ultimately that trajectory will lead to the emergence, you will see that we emerged as a species 200,000, 300,000 years ago. We tried to go out of Africa about 100,000 years ago. It was not successful. But then maybe about 70,000 years ago, we managed to go out and populated different parts of the world today. And as we did that, we both mingle with, for example, Denisovans and Neanderthals, but also did some damage, as I said earlier. And the Americas would not, of course, be populated until much later, after maybe 15,000 years ago. And as we do that, our adaptation and migration are really largely mediated by climatic change, environmental change. And that's why I was underscoring the importance of the work, both in climate, environment, and the information that we can glean from collections like that we have in the field museum. And now, of course, we are all over. And I'm at the museum, so I must mention the importance of engaging the public, because ultimately the public decides. And that's why we should teach children about our origins, like I'm doing it with my kids here, or President Obama, or the Pope Francis when I was inducted at the Pontifical Academy of Sciences. Thank you, Torsten, for inviting me, and thank you all for your patience.
Well, thanks a lot, Zeray, for this wonderful talk. I'm sure there are some questions.
Thank you so much. That was so interesting and wonderful. I was just wondering, the site that you have in Ethiopia that is preserving not just the hominins, but also all these other big African megafauna. What is it about that site that makes that preservation so prevalent? Is it the geology? Did something happen like a flood? Did it all happen at once? I'd love to hear a little bit more about it.
Yeah, 3 factors. And first, if we just focus on Africa, we can assume that within the fluctuation, there were many favorable places for the flourishment of early hominids in many parts of Africa. Lakes and rivers, like you see it in Malawi and other places in Africa. That's number one. So the area was lush, covered with lakes, trees, and rivers. Those lakes and rivers then would allow the preservation of those remains, as I showed you that beautiful layer of, I call it sedimentary archive. But because of the tectonics, those ancient rocks are coming out due to uplifting and subsidence and other geological processes. So it's the fact that the area was lush, but I don't think it was the only area that was lush and green, that you had the lakes and rivers that favor the preservation, fast preservation of those remains. I don't think, a China skeleton like that, unless it's fast, it would have been butchered or become like, scavengers would have scavenged it. Or, if it was like open air completely, it would have decayed. So the fact that you have those lakes and rivers are favorable for the preservation and subsequently these uplifts and other geological factors. That's what makes this area special.
Fascinating talk. Quick question: how many individuals of Australopithecus were found so far?
Yes. So the species I described, Australopithecus afarensis, is one of the better documented ones. And in terms of individuals, I think we have now over 400 individuals. Yeah, but not all of them are great skeletons like this. Some may be represented by one tooth or a fragment of a leg. But these species, but also Australopithecus africanus, are really well sampled, and we can even talk about statistics to the extent that possible. So this species has up to 400 individuals.
Zeray, thanks. This has been terrific. My question is along those lines, which is is there any ability to sort of assess the abundance or sociality of Australopithecus in those situations?
Yes, there is a site called actually the first family. It's not at my site, it's where Lucy was found. And they found 13 individuals just at the site. And what was interesting is that they had adults, older individuals, they had males and females, they also had juveniles and adolescents at the same time, at the same site. So demographic studies are complex even today. So, but what came out of that study was they would not have been much different from what you see in chimpanzee, maybe slightly more evolved, quote unquote. So that site in at Hadar, with those 13 individuals, gives us a clue as to what the demographic patterns were. But that's how much you can go. Remember that we're dealing with open sites, open air sites. These are not burials. The rivers and the lakes are doing the job.
Yeah, hi, Zeray. When Dart described the Tong infant, he only had a skull and an endocast. He had no postcranial remains, so he sorted out the bipedality from the foramen magnum. But he did note, in terms of the brain evolution, it was only chimpanzee sized. And I forget my anatomy here, but there was some sulci in the brain that he made note of that put it on the human path. And since your animals in Ethiopia are older, I wonder, did they have that same sulcal pattern? And what is that sulci?
Yeah, that's the lunate sulcus. Yeah, it's a very good question, actually. So the lunate sulcus is this line here. This line here. And that's what separates your visual cortex from the more parietal aspect of the brain. And if that lunate sulcus is lower, let's say here, as opposed to being here, it means that the anterior part of your brain, including the prefrontal cortex, is so large that it's pushing it relatively down. So what you're referring to is the 40 years debate between the late Ralph Holloway, he passed 2 months ago, by the way, bright guy, and Dean Falk. One saw it was more anterior, and the other saw it was inferior. And what this discovery shows is that it was more anterior, meaning more ape-like. And the tongue child actually was included in our study. It's also more anterior, which is chimp-like. So that discussion actually was sort of still in this paper that we published in 2020 or 2018. So yes, it was a lunate sulcus that delineates the visual cortex from the more anterior portion of the brain. Thanks. Is that clear? Yeah.
Let's have one last question.
Thank you so much for a lovely talk. I wanted to ask, with the discovery of the Lomekwi tools, very firmly pushing back stone tool use to predate our genus, what are your thoughts on some of the more recent debates that we should reconsider how the habilis fossils are classified, and that with cranial capacity and morphology, they may be more similar to the Australopithecines than the rest of genus Homo?
Yeah, even before the discovery of these stone tools, people like Bernard Wood had placed some of the early Homo habilis and rudolfensis specimens in Australopithecus. That we now have the behavior of stone tool in Australopithecus does bear on that question for sure. But what these new discoveries, both Lomekwi and Dakika, suggest are that there is no jump, a sudden abrupt arrival of the old one stone tool, or the Acheulean stone, or the MSA, or the LSA. It's evolutionary. If you look at the Acheulean technology, which seems to have emerged, correct me if I'm wrong, around 1.7, 1.8 million years, it does overlap with the old one technology. So they both lived side by side. So as we go back in time, I think the evidence is going to be rare and rare. So what we said at Dakika is we have the occurrence of that behavior. We don't know what the frequency was. So coming back to your question, therefore, I think the definition of the genus Homo is going to be more nuanced because that behavior is also present in Australopithecus. But remember, we're not finding nice Acheulean stone tools there. Even we don't have the older one stone tools yet. Maybe people will find. So what I would say is if indeed Australopithecus was doing what Homo was doing, then we have to reconsider and then redefine what that means. But in many ways, I would say that we should identify species based on their morphologies primarily. Because really delving into the behavior of an ancient species for whom we only have the rocks, I think we should respect the rocks and make them speak what they tell us, not invent stories that have nothing to do with the morphology. When we know now the disjunction between behavior and morphology, even on creatures that are living today, I would be very cautious. But clearly very relevant question. And I think over the coming years, that's going to be one of the biggest questions in my opinion. As I told you, I'm biased. I'm a paleoanthropologist, but I really love that evidence.
Okay, thank you very much, Zeray, for this wonderful talk, and thanks for everyone for the stimulating discussion. Thanks.